Introduction, Navigation Aid. NavAid infrastructure is one of the three components of PBN, together with navigation specifications and navigation applications. NavAid infrastructure refers to the ground and space-based navaids and provides positioning capability. Aircraft functionality may include an inertial navigation system which can also provide positioning information. ECAU sets out performance requirements for navigation systems to support the different phases of flight. These performance standards are found in Annex 10, Volume 1 of the Chicago Convention. Navigation sensors, horizontal positioning, navigation aids, NavAids, primarily provide range or bearing information which is received by the aircraft's sensors. This information is then used to estimate a position, which can be compared to a defined flight path by a navigation computer. The primary sensors used for area navigation, laterally, are as follows: ground-based, VOR, bearing, requires two stations to estimate a position. However, poor accuracy means that this is not used by nav systems. VOR-DME, bearing range. The angular error from the VOR limits the maximum range for some navigation applications. DME, range, requires a minimum of 2 DMES, plus ambiguity resolution. To estimate a position, supports all navigation applications down to the final approach fix. Space-based, currently GPS, other global navigation satellite systems, GNSS, systems as they become fully operational. A 3D position solution is calculated by estimating the range from 4 satellites. Navigation sensors continue. Vertical positioning. There are 2 systems identified to support vertical navigation: barometric altimetry, BaroVNav. Barometric altimetry provides readings based on atmospheric pressure, temperature dependent. The approach path will become shallower in colder temperatures and steeper in higher temperatures. Geometric altimetry. Geometric altimetry is part of the 3D solution provided by GNSS. Vertical accuracy is quite good, but the integrity of raw GPS is insufficient for aviation approach applications. Therefore, other systems have been developed to overcome this. Space-based augmented systems, SBAS. Vertical accuracy is provided by SBAS, of which there are 4 systems covering different parts of the world: WAS, United States; EGNOS, Europe; MSAS, Japan; GAGAN, India; SDCM, Russia. Ground-based augmented systems, GBAS, supports precision approaches down to Cat 1 today. GBAS corrections could also be used by suitably equipped RNAV systems. As precision approach is not part of PBN, GBAS will not be addressed further in this module.
The role of satellite navigation in civil aviation is becoming more and more important. Airspace users have recognized the potential benefits that global positioning systems can offer in terms of providing a uniform navigation capability worldwide, and potentially allowing for the reduction of some of the existing ground-based navigation infrastructure. The American Global Positioning System, GPS, has been approved as a means of meeting the basic RNAV requirements, but there are a number of operational restrictions. RNAV is now being implemented in terminal airspace. Although the US Global Positioning System is extremely good, it has its limitations in terms of the limited monitoring network in place to warn users of system failures. EGNOS is basically a monitoring system to assess the performance of GPS and provide information about errors and system failures to users. It consists of a series of ground monitoring stations distributed throughout Europe, which measure the performance of GPS. These monitoring stations provide their measurements over a robust communications network to a master control center where the current performance of all the GPS satellites is computed and a message is created for distribution to users. This message is broadcast to users through 3 geostationary satellites, which which allow the signal to be received over a large part of the globe. In addition to providing the performance of each of the GPS satellites, the signals from the geostationary satellites can also be used as ranging sources and improve the quality of the position solution computed by the user receiver. With the information provided by EGNOS, the user receiver can compute a measure of the trust that can be placed in the position that it calculates. This quality measure is referred to as integrity and is very important for civil aviation.